Okay. Example 6 is just a hodgepodge of all kinds of different kinds of problems. Okay. Now, now on the very first one though, the very first one is just a drag substitution, and it's kind of a reminder of what a 2/3 power is. So I'm going to go ahead and substitute directly in. All right, so because there's not going to be a discontinuity. All right, so substitute in, you get 15. Yeah, 5 times 3. So 5 times 3. What is that? What is that? What are you doing to me? Lord of mercy. All right, you ready? There you go. 5 times 3 plus 1 to a 2/3 power. But what that means is it's a squaring and then a cube root, and not necessarily then a cube root. You could take the cube root first, okay? But I'm just going to do it last because I'm not sure if it's going to work out nice and neat. But we're going to find out. So that's what 2/3 power means. So your numerator is your exponent, and the denominator is your index, if you will. So this is 16, all right, squared. All right, so I'd have the cube root of 16 squared. Okay. Yeah. All right. So what is that? The cube root of 256. So the cube root of 256. All right. Look, and I'd be happy with it like that, but 256 is four, you know, four fours multiplied together. So I could simplify, even though I'm really happy here because joy. Okay, nobody cares. All right, so if I've got four fours, then I could take the cube root of three of them, and so that would be one single four, where I took the cube root of that, and that would be the 64 cube root of 64, and then that leaves me with an additional four left behind because there were four of them all along. All right, so that's probably what they have as the final answer, but I'm happy with that. Okay, all right, B. We've seen one like this before. It's a couple of times now, so a little practice on that. I'll go a little bit faster. Substituting in, we've got square root of 4. That's 2, 2 minus 2, and then 3. So it definitely is one where we need to do the multiplying by the conjugate. All right, come on there. All right, so I'm going to go a little bit faster. So it's the square root of x plus 1 plus 2 on top and bottom. Okay, so and the square root of x plus 1 plus 2 on the bottom also. Okay. All right, and then that gives us, being proper here, the limit as x approaches 3. All right. I'm going to skip a few steps here. My numerator is going to be x plus 1 minus 4. So x plus 1, that's for multiplying the two square roots together. I don't have to do any of the outside inside because they cancel out. That's why we chose this. All right. And then so that's x minus 3. And then I'm not going to distribute on the bottom because that x minus 3 is going to cancel with the x minus 3 on the top. And then I'll have the square root of, I need parentheses here, x plus 1 plus 2. Okay. Joy, joy, joy. All right. And so then, so we know this is going to happen. Bye-bye to you guys. All right. And I've seen this mistake a lot. Be super careful with this. That does leave me with a 1 in the numerator. Notice I'm dropping the limit notation because I'm going to go ahead and substitute right now. A 1 on top. And then on your denominator, I have 3 plus 1 square root of 4, 2, 2 plus 2. Done. Okay. All right. So this is interesting. I am being told to approach -3 from the left. Okay. Well, all right. So here's the thing. I see this 2x plus 6, and on the bottom, it also has a 2x plus 6. Well, that's interesting. So But if I'm approaching a negative value from the left, okay. All right, let's take a look at this. All right, so how should we go about it? So I've got the limit. Let's just try to clean it up a little bit first. The limit as x approaches -3 from the left. Okay. And then I've got this can happen. I can factor out a 2 up here. So I have 2x squared and then the absolute value of x plus 3. Okay. All right. And then on the bottom, I could factor out a 4. And then I have just a regular x plus 3. Okay, now here's something you need to know. We're acting like we don't have a calculator here. So here's what I need to know. Anytime I'm dividing the absolute value of something by itself or that flipped upside down, either way, it's either 1 or -1 depending on where you're at, okay? Depending on where you're at, it's either 1 or -1. Now, so I can't substitute the -3 in and see because there's a step there. The 1 and -1 is going to create a step depending on how it's arranged and where they're set up. All right, so I know that those two divided, if the result is a negative, then that's going to be a -1. If the result is a positive, it's going to be a +1. Let me just show you on a simple one. Oh, no, not that. That's weird. That's like, oh, here we go. Oh, yeah. Well, this is almost the thing we're talking about. All right, but let me just do a simple one. So we have x divided by the absolute value of x. There we go. This is that 1 and -1 thing I was talking about. So whenever the result of dividing those two, they were identical to each other, regardless of the absolute value, it's +1. All right. But then to the left, then of course that's always going to be positive. But to the left, that will be negative, and so a negative divided by its opposite is -1. That's what's happening. So it's exactly what we've got. So we've got a -1 situation here because dividing those two when you're to the left of -3 is a -1. So this is a -1. Okay. This is a -1. All right. Now, but then I've done two things. I know that that's a -1. All right. And I also know that I'm approaching, I have, sorry. I've eliminated the 0 over 0 thing at the same time. So getting rid of that is a -1. And then I can just substitute in. So I have, all right, a negative because of the -1 here. It's going to be negative, and now I'm substituting in. So it'll be 2 times -3 squared divided by 4. Okay, so this is going to be negative, and that's 9, right, times 2 is 18. 18 divided by 4, -9/2. Okay, I'm going to pause. We'll have that be half. So A through C on example 6.